Hello everyone, hello class. Congratulations to all of you. We have reached our final unit of our class, so this is going to be our final lecture. Um, the rest of the day of the meeting that we have is going to be for quiz, practice, review, and test. Today we are working on system and equation, and we are going to focus on 2x2 system. The purpose of our class today is to learn the three methods that we have for solving system equations. Okay, 2x2 system of an equations. So excuse me, my voice, if I've been sick the entire past weekend. So so if you don't understand something when I'm speaking, just ask me for repeat myself, and I will do that as well. I will do that gladly. So, excuse me. Well, we are going to be focusing on our. Yeah, Benjamin is still a take-home test. Yes. What we are going to be focusing are in 2x2 system. This is a lecture that is already uploaded on Blackboard. Okay, a 2x2 system. What does that mean? Is that we have two equations. In our class, we are going to focus on linear equations, system with just linear equations. Okay, so and what do they have in common? Is that they have the same two variables. Okay, so this is a system because a 2x2 system because they share x and y variables. Okay, and what is the objective of system and equation? Yes, Timothy, I'm feeling okay. I'm better now. Thank you. Just my voice and my throat is a little bit not in optimal condition, but I'm okay. Okay. The objective of when we say we solve this system equations is when we find values for x and y, those two variables. Okay, it could be a, b, doesn't matter the letter that we use for the variable that are. Yeah, those are the solutions. Yeah. Okay, so when we find values for x and y, or the variables that are considered part of the system, that solve values that makes both equations at the same time true. Like Timothy said, x equal, what value did you say? No. I might check. I don't quite remember if they are the same. But you said x equal 2, y equals 1. Are those the number that you said? Perfect. Okay. So yeah, those are the values that make both equations true. And what does that mean? Making both equations true? Well, that means that when we plug in those values into our equation, both equations, we got the same thing on both sides. For example, 2 minus 1 is 1, that's good here, and 2 plus 1 is 3, that's good as well. So both equations are true with these values. Okay? So some system equations are very easy, relatively easy to just guess those values. What are those values that fits perfectly for both equations? And this system equation, this 2x2 system equation, is a good example of those systems that we can just guess, or you can, in our mind, we can find those values. The problem with system equations is that sometimes they are not so obvious, and then if we want to do a guess, gain for the two values that fit perfectly, or solve the system, we could have been we could spend an infinite amount of time trying to find those values, because there are infinite amount of values that we can try and plug in here to see if they works with the system. So instead of just guessing what are those values, we are going to learn three methods. The two methods that we are going to learn first is substitution and elimination. The third method then is going to be the graphical method, just graphing the equation that we have in the system and finding any intersection there is any. So here are the steps for each method. Okay, so we're going to start with substitution. Okay, this is the same system that we just saw previously. Okay, but now we're going to solve it using substitution. Okay, and the first thing that you want to do when working with substitution is to identify the equations. You can identify the equation by, for example, here by colors, but that is not so practical if we are working on a test. Another way to identify the equation is by using letters, like I did here. I like to use capital letters A, B, and C. If you have three equations, it's a 3x3 system. This way I can follow my steps. Okay, it's very important that each step here you are confident in your step and you make sure that you are doing it correctly, because you will see that solving systems of linear equation, sometimes it will get very tedious and it will get very a long process. So you don't want to miss any step. If you carry incorrect sign at the beginning or the middle of your process, the entire solution is going to be incorrect, and then it's going to be very difficult to identify your mistakes so you can fix it at the moment. So careful with each step that you are going to take here. That's why I always like to identify my equations. I always like to know which equation I'm working with. So the first step, or step number one for substitution, is that we are going to solve for one variable. But for solve for one variable, we need to select one equation, and then we need to determine for which variable I want to solve. Okay, the equation that I'm going to select is equation A. In system, when we're solving a system equation, we want to avoid two things: fractions and negative. Okay, and that is going to give you a hint for which variable we are going to solve, x or y. Which one do you think is ideal here? If I'm going to select first equation, the equation that is in green, for which variable do you want to solve, x or y? That's correct. It's going to be easier to solve for x, because when we add both sides by y, yeah, we cancel this y and we cancel that negative, and then we are going to have a plus y here. So that is what we are seeing here, and by that way we avoid to be working with negative. Okay, so that's step number one. We have selected the equation for the variable that we are going to solve. Okay, that's step number one. We solve for one variable. See that we don't have a particular value here. There is no value. There's just an expression that depends on the variable y. So x right now depends on y. Okay? And that's what we want. Because the next step will be to substitute. We got this equation for step number 1. Now, we are going to use the next equation, which is equation B. Okay? This one came from equation A. And then, using equation B, what we are going to do is to substitute. Here is x, so we are going to substitute x with its equation, or with its definition that depends on y. Okay, so we plug in 1 plus y into x. In the second equation, or equation B, and now look what happened. Instead of having two different variables, now we have just one variable, and we can solve them for that one variable. We have like terms. We have one y and one y here, so two y's, and then we can solve for this value. We can solve for y. Once we substitute, one thing that you need to make sure is that you end with just one variable. Okay? Now we can solve for that remaining variable. So we can solve for y in this case. So we subtract both sides by 1. Okay, so 1 goes here, but negative. And then this is equal to 2. And then we divide both sides by 2. So we find out that y is equal 1. Okay? So y is equal 1. We have not finished our exercise because we have two variables. Okay? So we have the value for one variable. Now, we want to find the value of x. And the best way to do that is by taking the value of y that we have just found in the third step, and using, remember this equation from step number 1, when we select and solve for one variable, we solve for x there, right? So now what we need to do is to plug in y into this equation and solve for x, and that will give us x equals 2, and then we have the solution there. Okay? So these are the steps, the 4 steps to do substitution. Any question? Okay, so in this, the exercises that are in the review are the same that are in this presentation. Okay, so you already got the review on Blackboard as well, so you have around 20 something system to solve. That is in the review, so you can solve and practice from there. Okay, and then I'm not going to stop for practice. Right now I'm going to start practicing with these exercises after I finish with all the methods. Okay, so let's move on to elimination. Okay, and elimination is kind of fun because before we need to think of what is the best term or variable to eliminate first. Okay, so that is what we are going to do first. We need to determine which term or which variable is most convenient to eliminate first. So to do that, we need to write our equations, both equations, in general form. General form says that we are going to see the variables, okay? the general form always is going to have addition operation, not a subtraction. So that means if we have a subtraction, we need to pass that negative to the next coefficient or next term. Okay, we need to remember that we have coefficients. We need to be able to identify the coefficients, and usually on the right side we will have just a constant value. Okay, so this is the general form. So we need to translate these two into general form. Okay. Okay. So let's see how we are going to do that. So we have our two equations. So what I'm going to do is to rewrite my equation into general form. For example, we have two terms here. What is the coefficient of this first term? What is the value of the coefficient? No. I'm not looking for the value of the variables. I'm looking for the coefficient, the value that is in front of x. It is 1. Okay, so we have x, we have 1 times x. Okay, so we are good there. Now, what is the value of the coefficient of the second term? What's the value of here? With what sign? It is -1, okay? So remember, general form, we are going to convert if we have subtraction, that will be then addition, but then the negative will go to the next term. So the negative will go to the coefficient of the next term. So now we are seeing the general form of the first equation. 1 times x plus -1 y equals 1. Okay. Does this make sense? Any question regarding this? Okay. So let's see them here. Okay, so we have the coefficient in red and the change from subtraction to addition in red as well. Any question here on step number 1? Okay, so why we want to do this? Because we are going to eliminate one variable using both equations. So then what we need to identify is, in order to eliminate one variable, what we need to have is opposite coefficients. And that's what we have here. We have opposite coefficient in like terms. For example, we have the term with x. In both equations, the term with x, its coefficient is 1. They are not opposites. Okay? If we focus on the coefficients of the y term of both equations, we have the first equation, or the green equation, with -1 coefficient, and the yellow equation, or the second equation, with a +1 coefficient. So these two are opposite. That means if we add them together, we cancel them. Okay? So once we have opposite coefficients, now we can add both equations. Okay? So you see, we put the like terms together. So we have 2x. Then -1 plus 1 is just 0. So those are get cancelled. So we have eliminated the variable y, because 0 times y is just 0, and the constant term is 1 plus 3 is 4. So now that we have eliminated one variable, okay, using the elimination method, see what happened? Now we turned into just one equation with one variable, because this one got cancelled. The y variable got cancelled because 0 times y is 0. And then we can solve for the remaining variable, which in this case is x. Any questions so far? Okay, so now that we have the value for one variable, then we are going to find the other variable, and we are going to substitute that value in either of the two equations. Okay, so if we plug in x into the yellow one, we are going to find out that y is 1, or x into the green one, again, we are going to find out that y is 1, and that is the solution. Any question? Timothy, I read your question. Timothy, can you define basic principles? Yeah, because this is a good refresher, because we are not going to be dealing with relatively easily system equations. Okay, so you always want to remember those steps. Okay, because the system that we just saw, just an example, is a very easy system. You are going to see that you need to, those basic principles are going to be your steps to solve any system of equation, 2 by 2 system of equation. Okay, so you will go over them every time you want to solve them. Okay, with practice you will see that you can skip a few steps, but usually you're always going back to those principles. Okay, so we have what happens when we don't have opposite coefficients? What happens when we don't have opposite coefficients? So when we don't have opposite coefficients, what we are going to do, initially we don't have opposite coefficient. What we are going to look is for any coefficient that is -1. Okay? Why are we going to do that? Because we can take advantage of the -1. Okay? So we have the -1 here. So let me just move to the next slide. Here is our -1 coefficient. So that means that we can eliminate the terms or the variable y if we multiply the first equation here by 3. If we multiply the first equation by 3, then we are going to get 3x plus -3y equals 3. And then we are going to find an opposite coefficients. Okay? So when we don't have initially opposite coefficient, we are going to look for a -1 coefficient. But what happens if we don't have neither opposite coefficient and nor negative one coefficient? So if we don't have a negative one, so we are going to look for just a coefficient equal to 1. For example, that one is there. So it means that we are going to eliminate the x variable, and in order to eliminate the x variable, this is what we are going to do. We are going to multiply the first equation by negative 2. Negative 2, where did this value come from? Well, I saw the coefficient of 2x, I saw the coefficient of the second, of the x term of the second equation, and that is 2, so I need to multiply my entire first equation by its opposite value. So that way we can eliminate the x value. What happens when we don't have neither negative 1 or 1? Well, we can find common multiples. And here we have common multiples of 4 and 8. So that means that if we multiply the first equation by negative 2, then this 4 is going to turn into a negative 8. Okay? Remember that we multiplied the entire equation by negative 2. So here it's going to be negative 6. Here it's going to be negative 22, and so on. But most importantly is that we are going to get negative 8 on the first term here, on the x term of the first equation. And when we add both equations, we are going to cancel the x variable. So let's try this one. Let me give you 10 minutes to do this system, to solve this system by elimination. Okay? And I want you to tell me, what did you do in order to use the elimination method and to find the correct answer. Okay? So let's do 10 minutes working on this exercise. Yeah, and let me know if you have any question on the chat. Okay? Okay. Um, First, what problems did you find solving this system? What did you find any problems with this system when trying to solving it? Mm-hmm. Mm-hmm. Okay. I think Mohammed or who said that? Yeah. Okay, Mohammed, did you got any the solution? What values do you got for x and y? X equal 5, and you were solving for y. Okay. Okay. Which variable then you decided to eliminate? Which variable? Y. Okay, so I think yeah you did well there. Okay, Alex, you did 3 times the first one, 2 times the second one. Perfect, perfect. Okay, that looks very good. So what happened here? So first thing we are going to do the general form, right? And we don't find any opposite coefficients, so we cannot add them together and just eliminate one variable. Then um, we don't have -1 as a coefficient. We don't have +1 as a coefficient. There's no common multiple. So that means when we don't have neither of these three, that means that we need to multiply both equations, like you did. Okay, we need to multiply both equations. And here, I will eliminate x. Why? I will eliminate x because I don't want also to work with huge numbers in my equation. They are not going to be huge numbers if you want to eliminate y because it's 6 and 4. Those are relative small numbers, and we multiply them by 2 and 3. Is that so it won't be a problem, but always take into consideration um, the factors of the number that you are going to be multiplying. You don't want also to get huge numbers in our system because sometimes huge number can lead to more mistakes if we left one digit or something. Okay, so my recommendation this is to eliminate x, and we are going to do that by the same way Alex says. We are going to multiply the first equation by 3 and the second equation by 2. That way we can turn these two coefficients into opposite coefficients, and we have +6 in the first one and -6 on the second one. Yeah, Timothy, that's good. Yes, we always can figure out, guess those numbers, okay? But typically that will work with relatively easy systems, okay? When we are working with more complicated systems, we want to use these methods because they are precise and more quickly than trying to guess what values fits here. Okay, so now we are ready to add both equations because we have opposite coefficients, and then we find that y is equal to 0. Okay, and then with y equals 0, we can solve for x, and x is equal to 5. So the solution is x equals 5 and y equals 0. And why am I giving you the solution as a coordinate and not by x equal y and x equals 5 and y equals 0? Why am I using now a coordinate? That's correct. Yeah, the solutions in a system, when we graph those equations in a plane, the solution are a point where they intersect. Okay? So that is the graph method. How do we do the graph method? So this is our recommendation. We solve for y, so that means that we write our equation in terms of y. Then we are working with linear equation, so it will be two key points because there are lines. So two key points usually, or the easiest value to use is x equals 0 and s equals 1. We evaluate for the y, so then we have 2 points, we plot the points, and we trace the lines to the points. The lines could intersect each other, could be parallel to each other, or could be in top of each other. So that are the three cases when we are solving linear system equations. Okay? We could have three types of solutions. We could have an independent system. The one that we have been working with are independent systems where we have exactly one solution, and there is where the two lines intersect. Okay, where the two lines intersect each other is the solution of the system. We could have an inconsistent system that has no solution. That means that they are parallel lines, they never intersect to each other. Or we can have a dependent system. It has infinitely many solutions. The two lines are on top of each other. Basically, or practically, what we are going to get in a system, a dependent system, is two identical or equivalent equations. Okay? You will notice that when in the dependent system, when we might simplify one equation, and when we simplify it, we are getting the same two equations. Okay, so let's practice now how to identify an independent system, right? Using how to solve an independent system using the graph method. Okay. So the first thing is to solve for y. Y is to solve for y. This is more a recommendation, but we are used to write, if we are going to graph, right? If we are going to graph, we are used to have in the left side y, and then the rest of the equation that with the x variable on the right side. Okay? So that is why we want to solve for y first. Okay? So here we have the two equations, y equals 3x minus 2, and then the other one is y equals negative 2x plus 13. Okay? So we use x equals 0, x equals 1 to get 2 points for each of the lines here, for each of the two equations. And then when we look at the graph or at their both lines, the point where they intersect, it is the solution of the independent system. Okay, so x equals 3 and y equals 7. Any question with this? Okay, so now what I want to do is you to practice solving this inconsistent system. I want you to tell me how the solution of an inconsistent system looks like. Okay, I want you to use the substitution, elimination, and graph method. Okay, so we have, let me see how many we are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So I'm gonna create three three groups of 3. So one group is going to do the substitution, one group is going to do the elimination, and one group is going to do the graph. We are going to be working as a group around 10 minutes, and then when we finish our the group session, each group is going to share their solution and how the solution looks like. Okay, so I'm going to use breakout room. Yes. Okay. So we need three. So 1, 2, 3, 4. Okay. So I'm gonna create them. It's going to be assigned automatically. So I believe when I click on create, you will be taken into the group. Okay. Once you are in the group, just start working with your group. I will need to tell you which method I want you to use. So I'm going to create the room. I don't know if you are going to go directly to the breakout room. If that's the case, I'm going to enter your room. I'm going to tell you which method to use. Okay? So if that's the case, wait for me until I get to your room and I tell you the method I want you to use. Okay? All right, I'm hitting create. Never mind, I don't need to go there. I'm going to put the name of the group is going to be the method I want you to use. Substitution. Elimination. And graph. Okay, so you will know the method that you are going to use because of the name of the group. If you have questions, please send me a message through the chat. Jacqueline, Jean, and Nicole, you need to join their group, your respective group. Okay, so we are all back. So, substitution group, Alex, Benjamin, Jean. What did you find? Okay, 3y equals 20. Okay, so I'm going to give you a bit, maybe 2 minutes, two more minutes. Okay, so I'm going to, okay. And now elimination group, Jacqueline, Salma, Timothy. What do you find? I like that answer. Salma, did you say that? There's no solution? And what answer did you find? Or what it was? Mhm. And then okay, just stop there. You didn't reach to any like last step or something. Okay, I like that. I like that. Okay, let's leave it there for a moment. Okay, let's move to the graph group. Mohammed, Amina, what did you find? Mm-hmm. Okay, the graph did not intersect. Okay. Mm, okay. Okay, so situation when you are ready, just let me know what is. Mm-hmm. Negative 15, negative 15 or 50? So negative 15 or. Okay, perfect. Okay, so are you, with these answers that you have given me, do you think that you are wrong or right? You solve the system. This is this is false, right? This is false. This is false. This is an inconsistent system. That means that the problem here it will be the vocabulary. We said that there is no solution for this system. When we said that there is no solution for this system, that there is no x and y that could be plugging into both equations at the same time and get true on both equations. Okay, so the system doesn't have a solution per se when we are talking about x and y values that fit on those equations. But the solution of you solve the system because it is a consistent system. You got 2 and conclusion. This system is an inconsistent system. When you read something like this, which is false, or even the parallel lines, well, there is no unique solution to this system. There's no x and y. There's no two values for this system that we can plug in and both equations get true. Okay, so you did it right and you solved it. Your final answer is it is an inconsistent system. Okay. Okay, so when you reach to this, okay, this is going to tell you, okay, this is false. Well, it means that we have an inconsistent system. Okay, does that make sense? Were you expecting like getting x and y values on this? Okay, but that is not going to be always the case. When we are working with system of equations, we could have the independent system where we are going to get x and y values. We could have the inconsistent system where there is no solution. Okay, so our solution will be something like this, something that is false. It is an inconsistent system. Or we could have an independent system where we are going to find many, infinitely many solutions. Okay, we are going to work on that one just in a moment. But what you did there, both the three of you, the three groups, did right because you got to a solution that tells us this is an inconsistent system. Okay, so if you see something in Spanish, just omit it. It is not part of our class. Yeah, go ahead. When you got x, what x equals something? X equal what? No, at that point, you just double check that all your steps are correct, or maybe look at the graph. If you have parallel lines, this is I think this is the most convenient because we have the graphic calculator. You can put the equation in decimals, for example, and if you see the graph that there are parallels, that there is no intersection, that is going to confirm your findings. Is something that doesn't make sense. Is when you are trying to solve for x and you get something that is false or a contradiction, it is an inconsistent system, and you don't need to continue working towards the other pair. Okay. Any other question with inconsistent systems? Okay, this is very important. Keep in mind that you could solve system of equation by finding three types of solutions. Okay, a independent system, an inconsistent system, or a dependent system. Okay, you need to have an open mind in terms of the solution that you could find. You could find x and y equals something, or you could find something that is a contradiction, something that is false. That's going to tell you it's an inconsistent system. Okay. Any question before we move to a dependent system? Okay. So now we are looking at a dependent system. Okay. What we want here is to see how the solution of a dependent system looks like. Okay. So let me try to do elimination here. Let me copy this. Let me open a new page. Okay, so if I'm going to do elimination, what would you recommend to me to do? Eliminate all the negative. So do you want to eliminate the y variable? Is that what you want to do? Okay, so we have 6 and we have 8. How can we make these two opposite to each other? We could do that. Yes, will be it will be a which one? -4. So for the purple one, okay. So we are going to multiply the purple one times -4. Okay, so that will give us positive 24 here, and the second one times positive 3, you said? Okay, perfect. So let me rewrite this here. So we have -4 times 3, that's -12x. Then -6 times -4 is positive 24y, and here we have 12 times -4, so -48. Then with multiplying 3 times 4, we got 12x. Then we got 8 times 3 is 24y. And then we got 16 times 3. How much is that? Is 48. Okay, so cool. We have found opposite coefficient, right? So let's add them together. 0x, 0y. So what we are getting here, 0 is equal to 0. Okay? Whenever we have something like this, okay, it could be 1 equals 1. It could be any other number, -3 equals -3. Usually what we are going to get is 0 equal to 0. Okay? These are very uncommon to see. But when we got 0 equal to 0, it means that we are working with the same equations. Okay? So they are dependent. Okay? This system of equation is dependent of each other. Why is that? Because when we can, if we look at the graph, if we go and do the graph, here is the graph of both equations. They are just, there are two there, but they are on top of each other, so at the end it's just one line. Okay? So when we got to that point, let me go back here. When we got to this point, the solution is this is an dependent system, and that's it. Okay, so those are the three, we have seen the three type of solutions. Let me go back to here and let me put the type of solution that we're going to see. Okay, so for an independent system, we are going to find something x and y. So we are going to find like coordinates. Okay, for the inconsistent system, we are going to find something that is false or a contradiction, something like 3 equals 5. And for the dependent system, we are going to find something like this, 0 equals 0. Uh-huh. Timothy, yes. If is the device that we are using, or is a tool that we are using allows us to do multiple type of lines, that is one way to show that there are two lines on the same place. Mhm. Okay. So those are the three types or three cases that we are going to be working with. We are going to be dealing with 2 by 2 system, okay? You need to understand the three methods of solving a system, and you need to have an open mind when we are getting to the solution, because sometimes you might panic if you find something like this in a math test, right? You see, well, 3 equals 5, that is completely wrong, but you need to remember, oh, this is telling me that we are working with an inconsistent system, okay? It is not always the case that we are going to find x equals something and y equals something, okay? So keep this in mind. It is very important. And the way you give the solution, if we have an independent system, you will give the solution by the values of x and y. You can write a coordinate. Okay. If we find something like this, you will say no solution, or you could say inconsistent system. And if you find something like this, you will say infinite many solutions. Or you could say a dependent system. Okay? That is how you solve those problems. Any question on this? Okay? So this presentation, you have the presentation on Blackboard. I believe you don't have the slide with Spanish and these pictures. Okay, so if you do, just omit them because they are in Spanish. The most important thing is that the exercise that you have. These exercises are also in the review. So the review and the exercise that you are seeing on in this presentation are the same. So I'm gonna stop the recording here, and now this is time for you to start practicing. So you go and pick up uh, some exercise that you want to try, and show me what you got. The quiz, we have quiz on Wednesday. So what I'm going to do, because we don't have too much time of practicing, I'm going to tell you uh, which exercise are going for the quiz. Okay, so let me stop the recording here.